Okay, so this is our third demonstration. No, third? Fourth? Fourth. Okay, what have you got in your hands there, Ms. Thomas?
I've got two solutions that have precipitated. They're both hydroxides, and it's to show you that this one on my right is a brown precipitate, and this one that also looks like a brown precipitate is one that is called an orange precipitate. So the brown precipitate is the silver brown precipitate, and the orange one is the iron 3 hydroxide precipitate.
Okay, so if we just zoom in on those. So the one on the right is, so the lighter one is the orange one, and the muddy coloured one's the brown one.
Yes.
Okay, good to know. They both could be seen as brown, and that's what catches people out, isn't it?
Yes. And if you only have the one that is orange, it could appear brown and then you think you've got silver. But of course, if you then do the confirmation, you will get the dark red.
Yeah. Okay. So now what are we looking at?
White precipitates.
Yeah, there's a load. When you look at the chart, there's about 6 or 7 white precipitates that form, isn't there?
Yes. So we've got two unknowns here. So taking a small amount of each into the test tube, again about 0.5 centimetre depth is all that's needed, and then 2 drops of sodium hydroxide into the tube and mix.
Okay, so if we go up to the chart, what we've done is we've added 2 drops of sodium hydroxide and we've got a white precipitate, and then there's an arrow down and it says add excess sodium hydroxide. So we've just added a couple of drops and we've got a white precipitate. When we add excess, as we've seen before, that's not 2 drops, that's a whole lot.
Now these are obviously 2 different solutions that we're testing, and the way they've precipitated is different. The one on the left all looks cloudy, whereas the one on the right you can see that you've got cloudy bits in the solution, but they are both white precipitates that have remained.
Okay, so on the flow chart it says add excess sodium hydroxide, precipitate remains, so our next box over here says new sample, add dilute sulfuric acid. So again, Thomas is getting a new clean test tube and adding those 2 unknowns again. We're just doing 2 side by side to save us having to repeat the whole process. So she's now adding a little bit of sulfuric acid, so just a couple of drops. And you'll see that one of them's got a white precipitate and one of them hasn't. So looking at the flow chart, add sulfuric acid. So the one that's clear solution is magnesium, and the one that's got a white precipitate is barium. So those 2 have now been identified. And now we're going to use another 2 unknowns that will give white precipitates. And which step are we going to start from?
So we're back at the add 2 drops of sodium hydroxide. So adding 2 drops, and it's very careful to make sure it is 2 drops, particularly bearing in mind the next stage of this one. So both of those have a white precipitate.
Okay, can we put them on the black background?
So we can clearly see that we've got a precipitate formed in both of those tubes. We're then moving down where it says add excess of the sodium hydroxide solution. And as that's added, both of those have now become clear solutions. You can clearly see through the tubes and there's no cloudiness left.
Great. Okay, so on our flowchart that now says we need to get a new sample and add 2 drops of ammonium hydroxide or ammonia solution. So that's what we're doing now, fresh new sample. And our choices have got a white precipitate which dissolves in excess, and a white precipitate that remains in excess.
So again, it's adding 2 drops of the test solution, ammonium hydroxide, also known as ammonia solution, and again, both of those give us a white precipitate.
Mm-hmm.
And then adding excess.
So when we're adding excess, we're adding about 3/4 of a tube.
And mixing.
Giving it a good mix.
And sometimes they take quite a bit of mixing, and you can clearly see that in the right hand tube there is no precipitate, and in the left hand tube the precipitate remains.
Okay, can you bring it up close there? Whoops. Okay, yep. So right hand one's clear. So that means the precipitate dissolved, so that's zinc. Is that right?
Yes. And then the other one where the precipitate remained, which was this bottle, we've got a further step to confirm which iron that is.
Again, a new sample, adding acid, and if it goes a white precipitate, it's lead. Colourless solution, it's aluminium.
So again, adding a small amount of the test solution, shake, and we have a colourless solution, so that has identified the aluminium ion.
Okay, great. Well, we're up to 6 minutes, so we probably should stop. Any other comments about those?
No.
No. The key thing here, of course, is to start with a small amount so that when you do the redissolving, you've got enough solution to redissolve. Okay, bye. Thank you for listening.